Hello and welcome back. So far we have seen a complete end-to-end process of executing a project or building a data science module or AI module by using linear regression algorithm and polynomial regression algorithms. We even did the best model selection also using two approaches. One is learning curve and the second is grid set CV, right? The cross validation techniques. So we'll use grid set CV a lot from now on. Okay. So we haven't done one thing, in the previous models. That is doing rigorous analysis, the exploratory data analysis on the data set, and then deciding whether to keep the feature or not. That's one thing. And for categorical columns, whether to do one-hot encoding or label encoding. We assumed that all the categorical columns are strongly related to the salary column, and then we did label encoding. So in this particular example, we'll do rigorous hypothesis testing, and then decide whether to go with label encoding or one-hot encoding. Let us try to jump in and understand what we do here. So I have imported the modules needed. You already know these. I have taken the data set here, right? And I'm looking at the head. Right? Head means it shows the top 5 records, and then splitted the data into train test. Right? The first step you need to do is split the data into train test so that there is a unseen data, the test set aside, right? And then you can test your code, the feature transformation or the data pre-processing code on the test set before we move into production. The second thing is you will test the model on an unseen data set. Okay, so you do the split as the first step. We have got 1209 records on the train set and 303 records on test set. Now we are actually keeping the imputation values for the numerical columns. So years of study, qualification, degree, and then educational institution. These columns we have actually taken the mode value and kept them aside. Okay, because this value is going to be used to impute or replace nulls in train set and test set both. So I have done it. You know this method, right? This method is actually doing the label encoding of the categorical columns. And we have kept the allowed values for the 6 categorical columns which are present in the dataset. The designation, qualification, degree, educational institution, gender and employee type. Right? So now I am imputing the values on the train set. Imputation done, and employee number column is removed because employee number is a categorical column, but it has got distinct values throughout. Right? If a column has got same value throughout or distinct values throughout, we'll remove the column. Okay, so we removed it because it is not going to add any value in predicting the salary. Okay, now let us try to do the hypothesis testing and decide whether to go with label encoding or one-hot encoding. So to understand relationship between one categorical column and a numerical column, we should do ANOVA, right? So when you do ANOVA, what you will know, right? Generally also you can do it. Generally by taking each group's mean, right? If in this particular designation column we have 7 groups, right? Senior developers, some senior developers are there. Analysts, some analysts are there. Senior analysts, some are there. All those people's individual group by salaries, if you take means, and means are different, that means the column is significant, right? A particular person's salary is different from another person's, or a particular designation salary is different from another designation salary. That means they are significant. But when you take mean, that may not give you clear picture because maybe only one director is there in your whole data set, and senior developers maybe you have 300. So the average actually for the senior developer gives you more clear picture, but in the director case it is not giving you a clear picture. In this case, the hypothesis testing helps you in deciding whether there is a significant relationship between the categorical column and the numerical column or not. So generally in hypothesis testing, what is the null hypothesis? There is no significant relationship between the input categorical variable and the target variable. That is, they are independent. So I have taken designation and salary because salary is the target variable. Designation is the exploratory variable, right? So I have taken these two and trying to understand relationship. The null hypothesis is designation of the employee and salary are independent, or designation is not important in predicting salary. That's what is the null hypothesis. The alternate hypothesis, it is important. They are dependent. To reject the null hypothesis or to say that there is strong relationship between designation and salary, the ANOVA test will give you p-value. If the p-value is less than 0.05, we reject the null hypothesis. Say that the designation and salary are strongly related. The p-value is greater than 0.05, we accept the null hypothesis. The designation is not related to salary and we remove the column. Okay. So here, designation has got 7 categories or 7 groups. If there are only 2 groups, we will use ordinary least squares algorithm and calculate a probability of the ANOVA test, and then do whatever the hypothesis testing. But when you have more than 2 categories, you need to do pairwise ANOVA. So we'll do that pairwise ANOVA here using multi comparison method from the stats models module. Okay. So here I have taken the cat plot and trying to understand the relationship between designation and salary at a high level. What cat plot will give you? The mean salaries differences, right? When you look at this diagram, it looks this graph. It looks like there is significant difference between each category, each groups, each senior developer salary, senior manager salary, and the means are on the y-axis and designation is on the x-axis. So there is significant difference. It looks like most probably we can do label encoding when there is significant difference between salaries or there is significant mean difference of the categories on the target variable. You can do label encoding because if you give hierarchical numbers, right, the senior developer 1, senior manager 2, like that, it gives a hierarchy or the feature gets some weightage. Each category gets some weightage. Okay. When you give weightage, the model will understand according to the weightage. Okay. So we can do it at a high level. But let us try to look at a box plot also, because there may be some outliers, right? In some columns, there may be some outliers also. So we haven't cleaned up outliers, and we know that the data is proper because we know the business, and for some people the salary is going to be high, and it is really high in this particular data set. So we haven't cleaned anything. Statistically, it may be showing some outliers here, but we haven't cleaned it because the algorithm need to understand the pattern. Okay. So now, if you do the ANOVA test, what it shows, we should see, right? The bar graph is actually showing that there is significant difference between the salaries and the designation. Different salaries have got different designations have got different salaries. But when you look at ANOVA test, what it shows, we should actually see. Let me run this code. When I ran this code, between each pair, right, analyst and director, it says reject true. That means what? The null hypothesis can be rejected. It means when you have analysts and directors, only those 2 groups data in your data set, they are strongly related. Okay. And again, analyst and junior developer also reject true. That means you can reject the null hypothesis and accept alternate hypothesis. That means when you have analyst, director, and junior developer, there is strong relationship. But if you see here, analyst and senior developer, there is not significant difference. So it says reject false. That means you need to accept the null hypothesis between these 2 groups. If you get all true, that means what? All groups, means have got significant difference, or all groups have got a significant relationship with the salary. So there is one column which is one pair which is actually having weak relationship with the target variable. So if all are saying true, you can actually do the label encoding. We have only one column which is having the weak relation, one pair which has got weak relation. So I have taken the one-hot encoding approach. Okay. So if all are true, you will take label encoding. If at least one is false, you will take the label and the one-hot encoding approach. What is one-hot encoding? In designation, we have got 7 different designations: analyst, senior analyst, manager, junior developer, and all that, right? So it created a column for each of these categories, and if the record belongs to that particular category, it gave 1. And if you notice this here, it actually is showing only 6 categories. 1, 2, 3, 4, 5, 6 categories only. We have got 7 categories in the designation column, but it is showing only 6 because we said draft first is equal to true. Why we are saying draft first is equal to true is that not to create strongly correlated columns. If you create for all categories different columns, it will create strongly correlated columns. If you eliminate one, what happens? If all are 0, that means the record belongs to the 7th category. Okay, to simply explain, if you have gender column and if you did the one-hot encoding, right, for male and female, it is going to create 2 columns. In male you will have 1, female you will have 0. In male you will have 0, female will have 1. When you try to calculate correlation between those 2 columns, right, it's going to be -1. When one is high, the other is low. One is low, the other is high. So when it is -1 and you are trying to build a model with linear regression algorithm, which is based out of normal equation, it will get into dummy variable trap, and the X transpose X will create a non-invertible matrix and it will throw error. But fortunately in scikit-learn it will not throw error, it will use pseudo inverse and then calculate your thetas. So not to create that kind of a situation there, we have said drop first is equal to true. The first category it will drop and create columns for all the other categories and then do 0, 1 kind of a thing. The advantage of doing this way is that the model will decide how much weight to give to each of these categories. Rather than the column, the algorithm will decide to give how much weightage to each of these columns. Weightage is nothing but the coefficient theta, right? So by doing one-hot encoding, we are adding more columns to the dataset. I hope you understood the one-hot encoding, and we'll do further the hypothesis testing on the other categorical columns also, and then decide whether to go with the one-hot encoding or label encoding. Thank you.